Hello everybody, my name is Akash, aka Nifty DGen, and I am the Bonfida intern. I'm here to talk to you guys today about our Records V2 initiative. So for those of you unfamiliar, you can actually set up different pieces of data associated with your SNS domain, which we call records. Now there's a long list of things you can set up a record for, but there's a couple of issues that arise with this that Records V2 aims to fix. The first issue is going to be staleness. So imagine you set up a URL record for a domain that you own, but you end up selling that domain. Since the record is associated with the domain, the new owner inherits that record. The record is now stale since it's no longer relevant to the current owner. The second issue that arises is verification. For instance, how do we know that the Ethereum record that you set up for your domain actually belongs to you? So we want to make sure records are fresh, i.e. not stale, and we want to make sure that the records are verified. So our various SDKs make distinguishing fresh and verified records really simple, and we can look at some examples of this in code. So I've quickly set up a boilerplate Next.js app, and I've downloaded the various libraries that we'll need to get up and running. Now, much of this is going to be standard to any Solana D app, but we'll also be using Bonfida's SPL name service library. Linked in the thread below are our developer docs in case you want to check out all the different tools we offer developers, or in case you need clarification on anything. So we'll specifically be using the verify staleness and verify right of association methods made available to us by the SPL name service library, as well as the records and guardians. I'm going to import all that real quick. Great. And we'll also need to pass a bit of data to these methods to get back the information we need. So I'm going to set up variables for the connection, domain, record, and verifier. Amazing. And now let's look at verifying staleness first. So again, this is so powerful because as you build out your applications, you want to ensure that the data that you're getting about your users is as up to date and as relevant as possible. And if a previous domain owner set up a record for a domain, we don't want to use that record to tell us anything about the current owner. So we can quickly implement the verify staleness method. It's really simple. We just need to pass the connection, the record that we want to verify staleness for. In this case, we're going to be using backpack, and the domain string. Since I've got all these set up as variables already, we can simply just call the method, passing in these variables, and for the sake of time, we'll look at the response in a console log. So let me set up a use effect real quick. And let me give it this fetch staleness function that I already have set up here. And I need to call fetch staleness. There we go. And let's give it a refresh and see what the response looks like. Fresh record is true. Amazing. So it really is that simple. And you can use this information to make sure that you're getting up-to-date and relevant records specific to the current domain owner. So let's quickly look at what a stale record would look like. So what I'm going to do is I'm going to simply transfer this to a different wallet address. And great, I will go back to our code now and I'll give it a little refresh. As you can see, the record was fresh beforehand. After refresh, we should see that it's false. So I hope you can see just how powerful this is in making sure that your applications are getting the most relevant and up-to-date data as possible. So next up, let's look at verifying the right of association. Now, a right of association uses on-chain and off-chain oracles to verify the legitimacy of a record, and in both cases, verification is extremely quick and efficient. And we currently support this for Backpack, for URLs, for Sol, and for ETH records. And in today's example, we can verify the legitimacy of my backpack record, but imagine the implications of this in your applications. For instance, if you want to do a NFT gated mint specific to users of Backpack, you can use verified records to make sure that only legitimate users are allowed to mint the NFT. Now, using the verify right of association method, we need to pass a connection, the record in question, a domain, and a verifier. Now the verifier is the known public key of the oracle that we want to use. So let me set this up real quick. I'm just going to comment out this previous code. And I'm going to copy over this fetch function that I have set up. Now let's call the function. Oops. Great. And let's take a look at our response. Now you're going to see that ROA is true. We have a right of association, and we can verify this by going back to sns.id and checking my backpack record. Backpack ownership is verified, and as such, our ROA is returning true. So as you can see, we're making it really simple and efficient to get this really powerful data, and it's so easy, even your intern can do it. Now, these were just some really basic examples of how we can use the functionality of Records V2, but you can get as creative with this as you'd like for your specific use cases. The purpose of the initiative was to improve on-chain trust, which is another step towards our goal of creating a more human Web3 experience. As mentioned before, we're happy to help you guys get set up with Records V2. Please feel free to reach out to us on Twitter or on Discord. And you guys might have noticed we've been cooking nonstop. There have been a lot of changes to our UI and UX recently, and you can expect more of that in the coming days. Until then, intern out.